So we're going to talk about the area of a region between two curves, which actually probably we'll be able to figure out pretty quickly. So how do you find the area? We're going to use two colored pencils for a second. So we're going to try to find this green area between f of x and g of x. Well, if I look at just the area under f of x, it'd be all this stuff all the way down. So it includes that. If I look at the stuff under g of x, it's this stuff in the black, right? So if I want to find just between f of x and g of x, subtract, right? So we are going to find the area under the top curve and subtract the area under the bottom curve. Okay? So how does that look? Well, to find the area under the top curve, we do the integral from a to b of f of x dx, and to do the area under the bottom curve from a to b g of x dx. You can combine that to be a to b f of x minus g of x dx, because our rules apply. Let me put a bracket parentheses around that. All right, so to add to this, we're going to take the f of x minus the g of x and give me my area between. All right, so find the area of the region between secant squared of x and sine of x from 0 to pi over 4. Well, that would look like, I always draw a picture. It's important to draw pictures so you can see what you're dealing with. All right, so clearly this y equals secant. If you graph it on your calculator, you'll see that that's the secant. And this is the y equals sine. So secant of x is our top curve and sine is our bottom curve. So we're going to find the integral from 0 to pi over 4 of secant squared of x minus sine x dx. All right, so we have to remember some of our integration rules. Secant squared is the derivative of tangent. So the integral, the antiderivative of secant squared is tangent. And then minus the derivative of sine is negative cosine. So we're going to end up having plus cosine. All right, plus c, but since it's a definite integral, we're going to go from 0 to pi over 4. All right, so let's remember that tangent of pi over 4 is 1, and cosine of 0 is square root of 2 over 2. Subtract off tangent of 0, which is 0, and cosine of 0, which is 1. So now we have 1 plus square root of 2 over 2 minus 1. So in other words, the area is square root of 2 over 2. You can check that integral in your calculator for accuracy. All right, so what happens when one part's negative? So if you are dealing with your g of x here, and we have a positive area, and we're dealing with our f of x here, and we have a negative area. All right, so how would this work? Well, really, we need to add the two, right? So let's do that. We're going to do integral from a to b of g of x dx plus we want the area of that under there. That is the negative a to b of f of x. So g of x is on top this time, so be careful. It's reversed from what we had before. But because this was a positive and it asks to have the area, what we're dealing with is trying to find the area between the two curves. Since that's a negative, we need to have it be a positive area. We end up having to do, because this is negative, we need to put an opposite negative out front to make the whole thing positive again. So really what happens is we're still doing the top curve minus the bottom curve. In other words, the formula still works, and the negatives work themselves out. So we have the area, the area equals the integral from a to b of the top curve, minus the bottom curve. So I won't put f and g in there, dx or whatever you're doing. I won't put I won't put F and G in there because it depends on which one's on the top. Like on this one, G was on the top, but on the one before, G was on the bottom. So I should fill in this other thing. So this has to do with if F of X is less than or equal to G of X, then we can add that little caveat in, and we can do the area is equal to F of X minus G of X dx. That formula works. So whatever's the bigger one, you put on top. You subtract from the smaller one. All right, so if we want to find the area of the region enclosed by this parabola, given by this function, y equals 2 minus x squared, and the line y equals negative x, how do I do that? Well, first you have to know, so you're trying to find this enclosed region, so you have to find these intersection points. Well, you can do that on your calculator if you like. If you don't have your calculator, you can solve the system. All right, so you'd have negative x equals 2 minus x squared by substituting y in. That's what I did. So if I want to solve this system, I'd have x squared minus x minus 2 equals 0. So if I want to keep by doing that, I just move this stuff over to the other side. Okay, so now let's factor x minus 2x plus 1 equals 0. So x equals 2 and negative 1 are going to be my solutions to the system, so substitute back in. So this is 2 comma, let's plug it in, it would be negative 2. And then we would also get over here negative 1 comma positive 1. When I substituted it into this equation because it was the easier. So we really need to take the integral from negative 1 to 2. And our top curve for that whole area, that whole region, is 2 minus x squared. We need to subtract off our bottom curve, which is negative x. And we need to take the antiderivative rather with respect to dx. So we can simplify a little bit before we take the antiderivative. We're going to take the antiderivative of 2 plus x minus x squared. I just rearranged the terms. And now we can take the antiderivative a little more easily. So we're going to get 2x plus x squared over 2 minus x to the third over 3. And we need to do that from negative 1 to 2. I'm going to go up here to this other column over here. So we're going to substitute in. We get negative 2. I'm going to do that backwards apparently, so let's do that again. We're going to put in 2 first, so we get 4 plus 4 over 2, which is 2, minus 8 over 3, and then subtract off negative 2, putting in negative 1 now, plus 1/2, plus 1/3, because the negative. All right, now I'm subtracting that whole thing off. So let's see. I like to distribute my negative. I see that I have a thirds over there, so I'm going to end up with a plus 2, a minus 1/2, and a minus 1/3 when I distribute my negative. All right, so let's see. I have 6, 7, 8, and I have minus 9/3 when I combine my thirds, and I have minus 1/2 still. So I have 8 minus 3 minus 1/2. See, I wrote a third, but 1/2. So that's 5 minus 1/2. I should get 4 1/2.